So far we had some preliminary introduction to Vedic mathematics, and we have been talking primarily about arithmetic. But let no one conclude out of this that Vedic mathematics is only arithmetic. I would just like to show to you today a book published in our times, and this is on higher applications of Vedic mathematics. In this book you find applications of Vedic mathematics in different topics of areas of mathematics. Just to mention a few of them, you have a separate chapter dedicated to topics like calculus, both differentiation and integration, nonlinear differential equations, solution of integral equations, and even solution of transcendental equations. Like for example, the Kepler's equation, which is used in positional astronomy, can be solved directly by using Urdhva Sutra. Then you also have a chapter on trigonometry, where you have computation of trigonometrical functions and their inverse, transcendental equations, solution of triangles, plane and spherical both. Then you have a separate portion on coordinate geometry, where you have topics on line and circles, transformations, and coordinate geometry in 3 dimensions. Now we find a very interesting thing. After my study of Vedic mathematics, I found that if you use the Tribhujanga approach of Vedic mathematics, then learning of trigonometry becomes a job with smiles. And I feel, with my limited understanding of trigonometry, coordinate geometry, whatever coordinate geometry and trigonometry we are teaching in 10+2 as per the books of NCERT class 11 and class 12, I can teach the same thing to students using Tribhujanga approach, and after this they will be in a position to solve more than 98% of the problems given in any book of trigonometry and coordinate geometry, which falls under the syllabi of +2, and the time required, you will be surprised to learn, will be 1/4 to 1/10, and bulk of the formulae and the equations and identities, which today somehow we feel must be mucked up, are necessary, they are not required at all. So in our subsequent lectures, when we talk about Tribhujanga approach, we will look at the application of these simple crisp sutras even to solve these complicated problems of trigonometry, coordinate geometry, trigonometry even plane and spherical. Yes?
As a Tribhujanga approach, it refers to angles or just plain old trigonometry?
That is a very good question. I thank you for that. I would just like to mention, it is not the topic of the day, but since you have raised this issue, I would definitely like to mention to you what I mean by a Tribhujanga. Tribhujanga concept of Vedic mathematics is a very important concept, and we find in the Sulabh Sutras the use of Tribhujanga, ancient Sulabh Sutras, and a Tribhujanga is nothing but
Triangle.
a set of three numbers which expresses the three sides of a right angle triangle, right. So, we are familiar with the style of representing an angle as an angle, but in the Bhujanga approach I express this angle as 3, 4, 5.
Okay.
So, these three digits 3, 4 and 5 form a tribhujang for this angle theta, that is the thing. So, anyway, just hold on, we will come to this and we will see detailed applications of this, but I just wanted to mention today as the first thing, let nobody think that Vedic mathematics means only arithmetic, no. But of course, I am sure you will agree with me, unless we know arithmetic thoroughly, unless we have mastered Bhaskaracharya's Leelavati thoroughly, going ahead will be very difficult. But I would like to mention one thing here which is very important, and that is this: भास्कराचार्य लीलावती के बाद जो हमें दूसरा भास्कराचार्य की पुस्तक मिलती है वो है भास्कराचार्य बीजगणितम. It is published with translation from Pune, and you find in Bhaskaracharya's बीजगणितम, Bhaskaracharya says वो मूढ़मती जिनको अंक गणित सीधा समझना आया हो, अब हम उनको बीज गणित की सहायता से समझाएंगे. What does it mean? This means, according to Bhaskaracharya, बीज गणितम is easier than arithmetic. It is for a dull-headed person. And today, what is the scene on the world stage? In class 5 and 6, algebra comes, and algebra comes in the class like a zebra, and the fallout rate, the failure rate exponentially goes up. There is something missing. I invite the mathematicians of the whole world to look into this issue seriously, dispassionately, with an open mind. How the hell Bhaskaracharya says those dull-headed people who could not understand Leelavati directly, which is simply a treatise on arithmetic, we will explain to them now with the help of Bijganitam, algebra. Bhaskaracharya was a genius. The whole world accepts this fact. Why did he say this? This is a big question. I know the answer. I am thoroughly satisfied with the statement of Bhaskaracharya, and I pray to Mother Saraswati to bless me with the buddhi, and to Mother Durga to give me the strength so that I can prove it before you. But I need the cooperation of all of you for this purpose. Now, coming to the topic of the day, we have so far been talking about simply the operations of multiplication and squaring. Today we start another very important aspect, and that is division. भाग करने के लिए भी हम देखते हैं कि वही निखिलम विधि जिसको हमने प्रयोग किया गुना करने के लिए, उस पर आधारित हमारे पास एक विधि है. बेस्ड ऑन द सेम सूत्र, निखिलम नवतः चरमम दशतः, Shankaracharya Bharati Krishna Tirth Maharaj presents before us in his introductory treatise on Vedic mathematics the Nikhilam method of division. Just like the Nichilam method of multiplication is suitable for division multiplication of numbers closer to the base, similarly Nichilam method of division is very convenient for division by numbers digits having digits closer to the base. Let us take an example. We shall take a very simple example. Let us say I want to divide 1 0 3 1 by 9. मान लीजिए हमें 1031 को 9 से भाग देना है. जो भी हमारा डिविज़र है, भाजक है, भाग देने वाला अंक है, भाजक है, उसके पूरक लिखेंगे निखिलम सूत्र से. एक ही अंक है, सो लास्ट फ्रॉम 10, क्योंकि निखिलम सूत्र कहता है निखिलम नवतः चरमम दशतः, ऑल फ्रॉम 9 लास्ट फ्रॉम 10. So last from 10, 10 minus 9 is 1. Now this is my MD. Mind you, MD doesn't mean managing director. This is modified divisor. हम अब सिर्फ इस modified divisor को ही यूज़ करेंगे. कितना आसान काम हो गया. हमें भाग 9 से नहीं देना है, भाग तो हमें देना ही नहीं है. अब भूल जाइए आप भाग कर रहे हैं. मॉडिफाइड डिविजर में अंक गिनिए कितने हैं? 1. हमने दाईं ओर से एक अंक गिना और यहां पर तिरछी रेखा खींच दी. ये हमारा शेषफल होगा, रिमाइंडर, और यहां आएगा हमारा कोशेंट, भागफल. पहले अंक को ज्यों का त्यों हमने नीचे लिख दिया, ये आ गया 1. अब हम इस 1 को इस मॉडिफाइड डिविजर संशोधित भाजक से गुना करेंगे. 1 into 1 1 1 इज 1, जिसको कि हम दूसरी अंक के नीचे लिखेंगे. I multiply this 1 with 1, the just obtained quotient digit, with the modified divisor. I get 1 1s are 1, which I write below the second digit. Now I add the second column digits. 0 plus 1 is 1. So हमारे भागफल का दूसरा अंक आ गया 1. Now again I multiply this with this. 1 1s are 1 and write it below the third digit. Now I add this column again. I get 4. So 114 is my quotient. And for finding out the remainder, I multiply 4 with 1, I get 4 1s are 4, and put it below the remainder portion. Add up this to this, I get 5 here, which is my remainder. If I want to have the answer in decimals, I can go on doing the same thing and I will get the answer. Okay? I will repeat this quickly. I want to divide 1031 with 9. Find the Purok of this using Nichilam Sutra, all from 9 last from 10. 10 minus 9 is 1. This is my modified divisor. Count the number of digits in MD, which is 1. After first digit, put a slash. This indicates our answer will have 3 digits. Now we are only modifying the answer, correcting the answer. Actually, if you look at it critically, by putting a slash here, I have divided this number by 10, right?
Yes.
But actually I wanted to divide by 9. So all this process is simply correction. If you look at it critically, all these steps which we are following is a simple correction. How we do that? You get the MD, first digit you carry down as it is, multiply it with this, 1 1s are 1, put it below the second digit, add up, I get again 1, 1 1s are 1, I put it below the third digit, add up, I get 4. So this is my correct quotient. And now 4 ones are 4, I write below the remainder portion, 4 plus 1 is 5 and 5 is my remainder. Now see a beautiful thing, I can even check the correctness of this answer, and the correctness I know that if this is E, this will be equal to Q multiplied by the divisor plus R. Now we don't need to write multiply the whole thing, we will only use Bijang.
Yes.
So Bijang of this is 1 plus 3, 4, 4 plus 1, 5. And now quotient is 1, 1, 4. Bijang of this is 4 plus 1, 5, 5 plus 1, 6. And divisor is 9 and remainder is 5. So 9 6 are 54, 5 plus 4 gives me 9, 9 plus 5 gives me 14, 4 plus 1 gives me 5. So this Bijang equal to this Bijang, this is the indicator that there is no random error. If we have committed some random error, they will not match. जांच की पद्धति क्या है, जो हमारा भागफल आया उसका बीजंक निकाला और भागफल के बीजंक को जो कि 6 आया यहाँ पर, 1 और 1 2 और 1 4 2 6, और डिवीज़र है हमारा 9, 9 6 का 54, 54 आ गया, रिमाइंडर है हमारा 5, 54 का बीजंक बना 9, 9 में 5 जोड़ा 14 आ गया, 4 में 1 जोड़ा 5 आ गया, और इधर जो हमारा नंबर है ओरिजिनल उसका बीजंक निकालते हैं जब हम, तो 3 और 1 4, 4 और 1 5, वो भी 5 आ गया, तो दोनों मैच कर गए, इसका मतलब देयर इज नो रैंडम एरर. नाउ लेट अस टेक a couple of more examples with the help of slides. Division by Nikhilam method. Let us say we are interested to divide 216 by 89. As before, I apply the Nikhilam Sutra and get the modified divisor. मुझे 216 को 89 से भाग देना है. 89 का पूरक मैं लिखूंगा संशोधित भाजक प्राप्त करने के लिए निखिलम सूत्र का प्रयोग करके. 89 का पूरक है ऑल फ्रॉम 9 लास्ट फ्रॉम 10, प्रत्येक को 9 में से घटाओ, अंतिम को 10 में से. 9 minus 8 is 1 and 10 minus 9 is 1. तो मेरा संशोधित भाजक आ गया 11, 1 1. अब क्योंकि मॉडिफाइड डिविजर में संशोधित भाजक में 2 अंक है, तो 216 में 2 अंकों से पूर्व यानी 16 से पहले मैंने तिरछी रेखा खींच दी. तिरछी रेखा खींचते ही क्या हुआ कि 216 को अगर मैंने मान लो 100 से भाग दे दिया तो उत्तर आ गया 2. ठीक है. अब मुझे दरअसल 100 से भाग नहीं देना है, मुझे भाग देना है 89 से. तो अब जो मेरा फिलहाल यहाँ 16 शेषफल दिखाई दे रहा है वो गलत है, इसको संशोधित करना होगा सिर्फ, और कुछ नहीं करना है. तो पहले अंक को ज्यों का त्यों मैं नीचे ले आया, तो 2 हमारा आ गया भागफल. I just carry down the first digit below and I get the first digit of the quotient. भागफल 2 आया. अब शेषफल निकालने के लिए मैंने 2 से गुना किया 11 को, दूसरे और तीसरे अंक के नीचे लिख दिया. 11 दूना 22 आया, तो 22 को मैंने 16 के नीचे लिखा. 6 के नीचे 2 है, 6 और 2 8 आ गया, 2 और 1 3 है, तो 3 आ गया. अब उत्तर क्या प्राप्त हुआ? My answer is quotient is 2 and remainder is 38. भागफल है 2 और शेषफल है 38. आइए, let's take another example of division of a big number consisting of 1011635 as we see in the next slide. I want to divide it by 987. The procedure is exactly same. लिख लीजिए सब लोग. हमें डिवाइड करना है 1011 को 987 से. अब हम सबसे पहले इसका संशोधित भाजक निकालेंगे. 987 का पूरक निकालेंगे निखिलम सूत्र से. 987 का पूरक कैसे निकला? All from 9, last from 10. So 9 minus 9 is 0, 9 minus 8 is 1, and 10 minus 7 is 3. Okay? So modified divisor is 0, 1, 3. And now we start the division process. Same steps. First digit 1 is carried down as it is. This is my first digit of the भाजक. पहला अंक जो 1 है उसका जोगत क्यों नीचे उतार दीजिए. आपका पहला अंक आ गया उत्तर का. अब इस 1 से आप संशोधित भाजक को गुना कीजिए. तो 1 को जब मैंने 13 से गुना किया 13 ही आया. लेकिन हमें यह ध्यान रखना है वैदिक गणित में 0 even on the left side or the right side is very very important. You will not ignore 0 wherever it may be. If you will ignore 0 you will do a mistake. क्योंकि वेद कहता है ये पूरे ब्रह्मांड का खेल शून्य से ही उत्पन्न हुआ है और शून्य में अंत में विलीन होता है. तो शून्य बहुत महत्वपूर्ण है और वैदिक गणित में भी शून्य का बहुत महत्व है. चाहे वो कहीं भी हो, कार्य करते हुए दाईं तरफ है या बाईं तरफ है उससे कोई फर्क नहीं पड़ता. अगर हमने 0, 1, 3 को खाली 13 मान लिया और 13 में 26 कर दिया तो कबाड़ा हो जाएगा. We will never be neglecting 0 wherever it may be. We will judiciously, meticulously follow the steps as we follow in a non-zero term and then get the answer correctly. So when I multiply with 1, 0, 1, 3, I get 0, 1, 3. I shift one column and start writing these below the second, third and fourth digit, namely 0, 1, 1. So in the transparency we can see the slide. The second line is giving that. Now I add the digits of the second column. दूसरे कॉलम के अंकों को जोड़िए. 0 में 0 जुड़ा, क्या आया? 0. वेरी गुड. अब 0 हमारा ऑपरेटर है. 0 को हम फिर 0, 1, 3 से गुना करेंगे. तो 0 से किसी को भी गुना करें उत्तर क्या आता है? 0. सो 0 से मल्टीप्लाई किया तो उत्तर आ गया हमारा 3 अंकों का और तीनों अंक 0 हैं. तो हम देखते हैं हमारे पास तीसरी लाइन में तीनों अंक ही 0, 0, 0 हैं. When I multiply modified divisor 0, 1, 3 with 0, I get 0, 0, 0 as the entry in the third line below column number 3, 4 and 5. Okay?
Yes.
Good. And now I add the columns numbers digits of the third column. 1 plus 1 plus 0 gives me 2. This is my operator now. And now with 2 I multiply 0, 1, 3. I get 0, 2, 6. Write them below the next set of columns, leaving one column again, and then add up. I get 4 as the last quotient digit. हमारा आखिरी भागफल का अंक आया 4. अब हम 4 से गुना करेंगे. 4 थी 12 आया, 1 हासिल का रहेगा और फिर 4 एकम 4 और 0. तो अब अंत में लिखिए आप 8 के नीचे 12, 3 के नीचे 4, 2 के नीचे आपका 0 आ गया चौथी लाइन में. सो इफ यू सी द slide before us, in the fourth line we write 0, 4 and 12. Remember 12 is a number at a single place. Okay. Now when I add 12 to 8 I get 20. Yes. So I get only 0 and 2 carry, and this 2 carry, now I add to 3, I get 5. 5 plus 6 is 11. 11 plus 4 is 15. So here you find carry has not been added. If I just add 6 to 4 I get 10. 10 plus 3 is 13. So 3 is written and 1 carry is written separately. And then when I add the columns of the third digits of the third column from the right side, I get 6 plus 0 plus 2 plus 0, which is equal to 8. So Now my remainder is, I add the carries, 9, 5, 0. So once again we see a wonderful phenomenon that using the same Nikhilam Sutra we can even divide, but when the division is by big numbers the problem becomes damn easy. यदि बड़े अंकों की संख्या से भाग देना है तो काम बहुत आसान हो जाएगा, यदि छोटे अंकों का काम है तो उसके लिए भी आसान तरीके हैं, इसके बारे में हम फिर चर्चा करेंगे. In Vedic mathematics the beauty is the complexity of problems is upside down. Dividing by a number consisting of big digits is very, very difficult today, but in Vedic maths it becomes damn easy. This is one of the beautiful features of Vedic mathematics.